Right, geez. I don't know if we can follow up a presentation like that. That was incredible. I feel like a bit of a hick, like a farmer just standing up on the stage. But let's see what we've got. Okay, so a little bit of background about Toronto. Let's see, we're a DFA, humid continental zone, year-round precipitation. It's quite warm here, hot summers. We have annual precipitation of 700, just 780 millimeters. Compared to other Canadian cities, it's actually not that much, right? We're fairly in the middle, but a little bit on the low end. Um, but we're a big city, and if you add everything up together, it's still a lot of water every year. Here's a map that you can make pretty easily from how many days have precipitation and how much total precipitation we have. So the red is percent of days with precipitation, and the blue is total amount of precipitation. Um, some of you with really good eyes might be able to spot Toronto. I don't have the laser pointer, so we're just in that middle plateau, but near the low end, right? So, we're in the middle. We're somewhere in the middle in terms of rain. Here's some more statistics about rain. About 40% of our days do have rainfall. 50% of those rains have less than 2.5 millimeters precipitation, so not very much, right? Most of it. Um, Typically, long duration rainfall warning from weather is at 50 millimeter, and very few days will have that much precipitation. However, we do often get storms, and the last really, really big one was 2013 with 126 millimeters of rain. I'm sure many of you remember that, might have been stuck in transit or in a car. Yeah, it was measured at the airport, and it cost 1 billion, nearly 1 billion of damages, according to the Insurance Bureau of Canada. There was a video from the CBC, but I don't think that's working. It is not. Okay. Uh, here's some stuff that was written about it. Let's actually just parse it down a bit. Right. So major transit halts, road closures, flight cancellations, several roads and underpasses underwater, sinkholes. Thousands were stranded, needed rescue by a boat. 500,000 households were without power, and 3,000 basements flooded. Um, Toronto did have a basement flooding protection program. We sort of accelerated it after this storm event. Um, Actually, one thing I want to point out, the statistics from before are based on days with precipitation. But usually, if you're actually doing statistics, it's about rainfall events. I haven't gone into that myself. This is the graph that's been referenced a lot about the increase in the amount of stormwater that the city want owners to manage, right? So I think before we were at 5 millimeters, but it's being increased to a lot higher. I think 25 was thrown around. It sort of depends on where you are in Ontario, and it's the recommended regional 90th percentile volume targets for Ontario. So it's 90th percentile exceeding 2 millimeters. Yeah, I mean, like Toronto doesn't get that much water, but we do have problems with water. So this is sort of what originally inspired Mark and I to start on this, and it's what got Susanna to work with us as well. Okay, right. So one of the reasons that Toronto do have issues with water is something called CSO, combined sewer overflows. Is anyone here familiar with this term or the concept? Yeah, I see a few hands, a couple of nods. So approximately 23% of the city have combined sewers. It's mostly in the older parts of the city, right? If anything is built maybe more than 50, 60 years ago, it's probably going to be a combined sewer. I'll have a few images to sort of explain that a little bit better, what a combined sewer is. But most of the times it just carries everything into water processing, right? So that includes all the sanitary water and all the storm water as well. Everything just gets sent to the four water processing plants in Toronto, and after that we'll put it into the lake. During periods of heavy rainfall, because we're putting that storm water to the water processing plant, it's actually not able to handle it, right? So that's why you get an overflow. All that excess water, the stuff that we can't manage, oftentimes just get dumped directly into the lake or the different rivers in Toronto. So it will fill beyond capacity, causing a combined sewer overflow, and it will typically contain a lot of bacteria, pathogens, other pollutants, a lot of nutrients. So with the green rivers and green lakes, it's because of these phosphorus and nitrogen, right? And that's why phosphorus and nitrogen are sort of the key things you want to measure for water quality. Okay, so a little bit more information about the CSOs. So you can see that in terms of sources water, there's the sanitary sources from inside any building, but then there's the storm drains on the street and from the roofs. All right, so during dry weather, everything works fine. All of it just goes into the water processing plants. But whenever there's wet weather, very often we'll have the combined sewer overflows. So ideally, you want systems like this. Right. So the sanitary water just goes into water processing, and then everything that's storm water that's falling from the sky, maybe runs along the ground or the roof a little bit, that's more or less okay going into the river. Ideally, there's a bit of filtration and a bit of processing, from low impact development like trees, rain gardens. Permeable pavement probably does limit total suspended solids. There's other benefits from other LIDs. So, right, here's a map from the Green Streets Technical Guidelines. So you can get a sense of where the combined sewers are. That's highlighted in yellow, combined sewer areas. Some of the separated sewers, there's actually a third version over here where the storm drains are separated, but the downspout isn't separated, right? So the downspout is still going to the water processing plants. I don't think I have a map of where that sort of in-between version is, but 23%, it doesn't sound like much, but looking at this map, that is still a very large area of Toronto. Right, and a very dense area. And it's the older part where it's very hard to break the ground and upgrade the pipe system. Right. Okay, from the City of Toronto website, they sort of describe a bunch of different projects that they're working on to help manage that issue of putting in nutrients into the lake. Now, if we look through this, a lot of these are what will be called gray infrastructure, right? Which is an important part of managing water in a city. But it's often things like treatment plants, facilities, pipes, and main sewage treatment playground, park usage and upgrades. It's called a playground. I haven't been there. I'm not sure how much of that is actually a playground, but it's mostly great infrastructure. This, of course, isn't all that the city is doing, right? The city is doing way more than just these projects, but on the city website, that's what they describe as what the city is doing to maintain combined sewer overflows. Here are some other programs that are really awesome that I've had to really tap into to get a better understanding of the whole thing. The city has a mandatory downspout disconnect, right? So if you think back before, all that water from the rooftop just goes right into the sanitary sewer. After the downspout disconnect, you're not putting it into the sewer right away, right? You're sort of putting it along the ground so that it goes into the storm sewer instead of the sanitary sewer. Wet weather flow management guidelines has a lot of really good information about managing storm sewer. If you're interested in this then it's a worthwhile document to just download and look at. Toronto has a Toronto Green Standard and has a Green Streets program and a Green Roof bylaw. So really, Toronto does have a lot of low impact development kind of support, right, and research. And it is something that we focus on a lot as a city. The wet weather flow management guidelines has something called a hierarchical principle, right? It's saying that ideally you want to prioritize source control. If you're able to capture that rainwater where it falls, then you don't have to worry about bringing that water to somewhere else for further treatment, right? So if you can prioritize source control, that is ideal. And that's sort of what got us thinking about rain gardens.
It is almost like the recycling program. So if you separate in the source, it's cheaper and easier to treat.
Thank you. Yeah, sustainability. Okay, so low impact development or green infrastructure, it's a little bit text heavy, sorry about that. It's a natural or human-made element that provides ecological and hydrological functions and processes. Components may include natural heritage features and systems, parklands, stormwater management systems, street trees, urban forests, natural channels, permeable surfaces, and green roofs. So this is from the Green Streets Technical Guidelines. Right, once again, a fantastic resource full of information and a very thorough appendix. The map that I showed you a few slides back was from the Green Street Technical Guidelines. Right, both are very important components of stormwater management. I think, right, so here are some examples of this. I'll get into the rain gardens in a second. We've all seen parks and swales. This, I would say, is more of a swale than a bioswale. I would prefer if there were more plants in there, just to provide more of a habitat for pollinators. This here is a stormwater management pond. So essentially, instead of just putting that stormwater directly into the lake, you leave it in the pond and let that filter a little bit, right? It filters and it settles, and it's cleaner water to put into the lake. Okay, we have the green roof at City of Toronto, the City Hall, and there's a green wall. I think that's at Brickworks, Evergreen Brickworks, but I'm not too sure. Right, and here's a very typical example of a rain garden. Important design features are that there's no curb. Nothing separates that paved area from the garden part, right? So if rainwater does fall on that pavement, it's able to just roll right into it. And here's another example of what we'll call a bioretention. It's essentially a rain garden. It's the exact same idea. Fairford Parquet, which was mentioned by David, our first speaker. And there's actually a very good case study that you should check out from STEP, Sustainable Technologies Evaluation Program. And I think they profile how much water it's able to process and what kind of filtration results we're getting out of that. There. So let's focus a little bit on rain gardens specifically. I think I'm rushing through this a little bit too fast. All right, so a rain garden, this landscape shallow depression is filled in with loose, deep soil that naturally filters stormwater and prevents it from entering our waterways. A rain garden is low maintenance and planted with beautiful, hardy native plants that attract pollinators and require little to no watering. So if you walk around Toronto, you'll notice many houses like this. Ever since the downspout disconnect, oftentimes these downspouts are just pointing at the driveway. Right. Some houses will have it pointing at their front lawn or into a garden that they have, which is fantastic, but many of them are just going along the driveway. This is still better than before because we're not putting it into the sanitary sewer right away, right? But now, because it's going along the driveway, it's causing a little bit more water damage. It's picking up a little bit more pollution before getting into the storm sewer. So it's better than before. It has saved us a lot of money, but it's still not ideal. So we're proposing things like this to different homeowners. right? This is actually Mark's garden. He's not able to make it today, but he sort of started with his own house, right? He was dealing with a very damp basement. And apparently, after putting this in, he hasn't had to deal with that nearly as much. There's still some dampness, but he hasn't had a flooding since. Let's see. Oh yeah, Homegrown National Park. We'll have a mention of that. I think the next slide. No, in a few slides. Here's a few more design considerations about rain gardens specifically. So let's see. There. A rain garden must be designed to take water from specific impervious drainage area, so roofs or driveways or sidewalks. Most of the rain gardens that we've been building are dealing with roof water, right, with individual homeowners. Rain gardens must be located at least 3 meters downslope from any foundations and filled with wall-draining soil. We're typically working in the east end. The soil is very sandy and it does drain fairly well. If it is more of a clay soil, you would want to remove a lot of it and then mend it, right? Mix it with the local soil and add a lot of sand to it and some compost to help grow with the plants. And thirdly, you want to use native plants that can handle both drought and wet conditions. And essentially the idea with a rain garden is you don't want to water it, right? This is one of the benefits with a rain garden in that instead of using potable water to water a lawn, you're using rainwater to water this garden. And because of that intermittent drought and wet condition, it's the best case scenario is using native plants. Right? If you're using a cultivar maybe imported from Europe, typically they have very narrow tolerance conditions. The other benefit of native plants is that they're also providing a pollinator habitat. So rain gardens do fit with the City of Toronto pollination strategy as well, which is one of the other reasons we want to promote it. Essentially, we started with the David Suzuki Foundation as a volunteer group. And I think that is the next slide. There we go. All right, so RGU started with Mark Yamaguchi in a flood-prone basement. He signed up for the Homegrown National Park. You saw a sign of that with the rain garden picture. This program has since evolved into the Butterfly Way project, which is the idea of creating a corridor of pollinator habitat across all of Toronto. Sorry, across all of Canada. Toronto we do have 2 different sites in the city that sort of have a high density of these kind of habitats, but it's also in Vancouver. I think there's some in Mississauga and some in Kitchener, I want to say. But yeah, look into the David Suzuki Foundation and the Butterfly Way project. I think I have a poster over there if you want to check it out. So from there, he applied for a grant from Toronto Foundation to create a pilot project, and he was able to build 10 rain gardens around the East End. And this was sort of the first year. I feel like this was before I even got involved with this. So since then, I've been working with Mark to install more rain gardens, and we have about 33 so far. Last year, we incorporated as a nonprofit, and we're trying to think of other things to do, right? So we're sort of approaching this whole problem from a different angle than all the others, sort of very highly trained and very professional kind of people that are in this room. We're more of a grassroots and sort of have to reach in every direction to see what kind of information we can get, what kind of support we can get, what kind of needs are there around the city. Here is a map of some of the gardens we've planted. So if you notice, we're almost entirely in the East End. There's a few more. I mean, we've got one over at Dufferin Street as well, but most of it is in the East End. Really, if you look at this whole area and how much are paved and how much is canopy or grass, it's not that much that we've added, or it's like we haven't really removed any paving, right? That's still there. We're just sort of enhancing the absorption ability of the green spaces around homeowners, individual homeowners. We're actually coming to the end. I mean, I'll probably say a few words in a bit as well about what I do. But if you're interested in helping out with this stuff, I mean, I think the key thing that I want to point out is anyone can look into this, right? Anyone can plant a garden, and if you can plant a garden, you can try and make it a rain garden, right? You can have this garden serve other purposes, ecological purposes or naturological purposes, whether it's to deal with the rainwater or provide a habitat. Um, if you are interested in this, it could be worthwhile to look up some research, some papers. So a very good one, I mean, you've probably come across a lot of these terminologies just this morning, right? There's people who've researched what they all mean and where they all come from and how they're used differently in Australia versus the Netherlands. Um, this is a really good one that I was using to justify um, greenhouse gas reductions using rain gardens. I find that a lot of the focus is on carbon, right? So if you can argue that there is a carbon saving by more of these kind of planting and rainwater harvesting, then that's a good argument to make. It's a bit of an old one, but I think this is what convinced, this is one of the things that convinced City of Toronto to have a green roof program, right? A green roof bylaw to see that there is a lot of possible energy saving and economic benefits. Now, we're mostly dealing with homeowners, so we don't really have to worry too much about policy. I mean, as long as we're not breaking any laws, as long as we're not hitting utilities when we dig, it's okay. But if you do want to do something on a larger scale, it would be important to understand some of the other factors that are involved in the city or in the province. Right? And there's another paper that's very similar to this that's based around the Great Lakes. So it's not even just a province, it's everything surrounding the Great Lakes. The bigger the system that you're looking at, the more complex it becomes. And even a small garden in the front yard can be very complex, right? There's a lot of things that it's connected with. So it starts getting a little bit unmanageable pretty quickly if you're just doing this by yourself. But luckily, I'm not by myself anymore. This is a really good paper from Eco Justice and Green Infrastructure Ontario Coalition about the different benefits of green infrastructure and low impact development. So health, prosperity, and sustainability. Very interesting publication to check out. It's just a few. I mean, there's a bunch more. Okay, so personally, in terms of what I do, mostly it's been a lot of SketchUp, right? So I'm sort of the concept design for Rain Gardens Toronto, Rain Gardens United. We would go to a house and take measurements of the roof, take measurements of the front yard. I would then go home and fire up SketchUp and try to just mock up the current site conditions, right? And then from there, try and design something that looks pleasing, that has the right dimensions. Typically, we recommend about a fifth of the roof area, right? So if you're dealing with something that's 100 square meters, then you want 20 square meters as the size of your garden. We typically do add another thing as well called a soakaway pit, right? That just helps improve infiltration as well. I think it is also listed as a best management practice. I'm not sure how common they are, but essentially it's just you dig deeper in the middle of the rain garden and fill it up with clear stone, pea gravel, and wrap that in landscaping fabric so that the sand doesn't clog it up. Right? It's something to improve the infiltration. Recently, ever since looking into policy and sort of larger scale stuff, I've had to learn GIS. It's been a lot of fun. You get some really pretty maps, and it's very confusing at times. There's a lot of emailing, coworkers and collaborators presenting talks. We did a presentation at the public library once, and I think we had 2 people show up, one of whom was a baby. So that was a fun presentation. A lot of research and development, a lot of planting and maintaining gardens. We're coming up on spring, so we'll probably have to go visit all of those 33 gardens, see how they're all doing, see if we need to replace any plants. Okay, that actually concludes my part, but I think Susanna, there's a new thing that we're looking into, so I'll pass on.
Thank you. So just press the middle button. Sorry? Yeah, that's okay. I'm fast. So like Ting said, we're amateurs. We just incorporated so we can look for more support, especially in terms of money, so we can expand the ideas. And one of the things we went into is the fact that we have to propose something that is the maintenance is good, or the longevity of the gardens um, or longer. So basically the resilience of the plants and the system that we want to do. So we're looking into, like Jeremy said, under the earth. So like we all talked about stormwater management and all that, so I'm not going to repeat everything. So we're looking for a low-cost alternative, and one of the things that we came into is biochar. So biochar is actually a sort of a charcoal, but it's produced in a different condition, and it has a capability of amending the soil and promoting not only retention of pollutants, but also growth for the plants. So as long as it absorbs the phosphorus and the nitrogen, then it is available for the plants. It also absorbs a lot of water, so it helps with the stormwater management, and it helps with making it available for the plant roots. So there's a lot of stuff that can be researched in the biochar. This is not a new technology. It's about 2,000 years old, actually. It's very common to see in excavations from the Native Americans here, and especially in South America. And in the Amazonic region, the land is very poor. There's a forest on top, but as soon as you take it down, there's only sand underneath it, and it becomes like the Sahara Desert. So the natives got a way of, found a way of producing their food and being able to make it productive. So therefore, we're looking into researching more and more about this and getting it certified and being able to produce it in Canada, which there's some companies already doing that, but we're after the information so we can actually use it in our rain gardens. So this is a lot more information about how the cells of the charcoal are formed, and that's the physics of it. It's how it retains water, and it can be used as a filter also. We're thinking also of a new technology of putting those on the supposedly linear drainages or something to collect the water from the parks. So before it actually hits the plants, it also has a pre-treatment and maybe take away some of the salt, some of the copper, the zinc, and all those pollutants that are out there in the parking lots. Thank you. We're open to questions now.